Yeah, so I mean, I think one of the most important things to get across at first is just that I'm coming from the position of an architect. So again, everything that I'm going to be talking about is through that lens. So don't despair if I disparage your favorite technology or whatever. But you know, again, I think there's a lot of technologies that are doing some interesting things, and I think some work in the realm of architecture, and others don't. So I see my slides are a bit large, but I think the main difference between architectural making and just kind of making in general, there's many different forms of making, is the idea that there's a translation process. And Robin Evans has a famous essay, Translations from Drawing to Building. And in a sense, there are two kinds of translations. And if you see, you know, I'm saying that Robin Evans makes a statement drawing to building, but really there's a whole bunch of translations that happen from floor plans to sketches to watercolors, and an architect might do a sketch and hand it off to somebody else, and then they turn it into a BIM model or they turn it into rendering, and then someone actually writes a specification. And then there's a giant translation, and that giant translation happens when someone collects all these things together, turns them into contract documents, and then hands it over to a contractor, and then that gets translated into a building. It's not entirely unique to architecture. There's I heard the fashion, one of the first speakers, I apologize for not remembering the name, but that you know, the fashion designer comes up with something and it disappears and comes back fully formed as a dress. But in general, makers are dealing with the medium and the final outcome quite immediate to them. And architects, on the other hand, are doing a bunch of virtual activities that then get translated into a large building. Now, the digital fabrication, I think, brings two, or can kind of exacerbate that notion of translation in a couple different ways, more than two, but I'm going to talk specifically about two. And one is, I should also say that I'm also an architect, but I'm doing my PhD and do some teaching as well at Carleton. And so a lot of this is directed maybe in some of the observations I see of the way students are approaching some of these technologies. So one of them being that there's this idea that you can just have this thing in the computer and print it out, and it's just this one-to-one thing, push the button, it's very easy. And I think that is a bit of an illusion, you know, propagated a lot by 3D printing. And again, if you are not taking into consideration that thing that you just 3D printed isn't the building itself. The thing that you just 3D printed then leads to a building. And so it's kind of problematic thinking about this kind of one-to-one. It's so easy, push a button. And I'm afraid that a lot of students are going to leave the schools, you know, with this idea that building is actually quite easy. The other one is kind of, I'm going to kind of facetiously blame Plato for this one, but it's this idea that, and so I see these kind of these two conditions where, so on the one hand it's easy, here's my idea, here's a physical reality, which is usually generally garbage plastic, and on the other hand there's this idea that anything, no matter what, you have the idea, and any time that it gets brought into the real world, there's some kind of degradation, or the word that I've been hearing lately is that it gets sullied. I heard a musician talking on the CBC, which I found really strange considering the difference between architecture and music. But he was saying you always start with an idea, and then when you turn it into a song, that idea gets sullied. And I just find that a strange kind of way to think about things, and I think a lot of people actually think that way. And I guess I'm challenging, and I think it's the wrong way to think about architecture, because if that translation process isn't working, then maybe that you need to have a different approach. I think this is a translation that a lot of people can appreciate. And this is a common, I guess, internet meme of kind of failed Pinterest. Someone sees some great thing on Pinterest and they try to do it and it doesn't work. So this is one kind of failed translation, and I think something that's kind of, I think, bubbling under the surface today is this idea of where does skill fit in all this if you're a digital fabricator or a digital maker. And I just want to back up a couple slides. This is just on your left is something I sculpted by hand inside the computer, and then that's a 3D print on the right. But obviously, if we actually look at this image seriously, you can see that this person actually had no clue what they were doing, trying to ice these cupcakes while they're still in the hot tin. And so I think one kind of translation and one kind of degradation of an idea to a reality is just a lot of people just don't have the skill or the knowledge to do it. And that's not to say that they can never have it, but that it actually takes practice and it takes time to develop skills and knowledge and to make things. But there's other ways that things can be translated and not be a success. This as well. So this is a project on the West Block. The point of this was to engage with stonemasons. So on the left is a real stone capital. On the right is a 3D print at a 1-to-1 scale. So you might be able to detect some seams because we had to print it in a couple different pieces. But essentially from a metric standpoint, it is a perfect replica. But on the other hand, it was completely rejected by the stonemasons because of the materiality of it. It was so alien to them. It was so different from stone and other materials that they use, plaster and clay, that they just rejected it out hand. So again, this is kind of a failure of a translation, even though it looks pretty much identical. This is one that's maybe more successful. This is the tympanum. That's the interior part of the arch on the West Block. And this was a CNC cut out of MDF. And this is something, although they were still kind of reluctant, they could actually, the material was more analogous, and they could see that the opportunities that this is maybe something that we could work with. The other aspect that concerns me about digital fabrication in architecture is this idea of control, that it's actually quite messy construction, and there's actually a lot of people involved, so there's a diversity of diversity of actors and a diversity of materials. And I think that a lot of architects are thinking of digital fabrication in a way that says, great, I can get rid of all these guys in the orange vest and just print something out or CNC cut something without their input at all, which again I think is an incredibly naive way to think about it. So now that's kind of some of my, I guess, position. I'm going to just kind of run through really quickly 3 projects. They're fairly different, and it's not to say that this is the right way to do things, but these are just 3 projects that I had a hand in, and some of the experience, I guess, that I got from that. So this, just very quickly, is on the East Block. This is working with Public Works and Government Services Canada, Heritage Conservation Directorate, and Parliamentary Precinct Branch. And this is a project through the Carleton Immersive Media Studio, and the main person that we worked with was someone called the Dominion Sculptor. He's a very, very talented stone sculptor, wood sculptor, bronze castings, everything. So this is just kind of, whoa, it's fast here. It's just going to kind of elucidate, I think, some of the workflows going back from digital to analog. So this is the this is the sculpture. It's a relief sculpture. It's very badly deteriorated. We digitize that. I'm also going to kind of use generic technical terms, and maybe those we can talk about that after, very kind of specific, but we digitize it. We create a replica with a CNC machine, and then if you notice the detail between the owl here and this owl, and that's because after we cut a replica of it on the CNC machine, we give it to the sculptor. He applies a layer of clay by hand to bring out the details again. And I think one interesting thing about the translation, this is clay, and you can see he used a specific tool to apply that clay, but that is not necessarily the effect that he wants to have in stone, so there's kind of another translation process that happens. And along the way, there's the digital, which can cause strange artifacts, again, depending on whether you know what you're doing or not, and whether these things are good, or if there's opportunities for weird things to happen, might be good or bad or whatever. But at this time, we were kind of new to this. Digitize it again after the sculptor applies his clay. So now we have a virtually kind of restored version. And then we approached a robotic fabricator. This is a test again out of foam. And this is another big thing. There's a big difference between milling with foam. And this is what I'm talking about, how easy it is to print something. You just hit print and it appears, or CNC mill. Foam, it is actually quite easy. When it comes to stone, it's actually quite difficult. And he actually misled us into believing that he had worked with stone. And so there's this whole process of trying to figure this out, and it took way, way longer than it would have if it had happened by hand. But this is the final result from the robot. Then it goes back to the sculptor, and you can see on the left, that's his work by hand, so he's adding a whole nother layer on top of that. And this is still kind of divided in half. On the left is his work, and I always say when I show this image, it doesn't do it justice. Is actually, what his work brings to this is actually tremendous, tremendous to the final product. And I just wanted to put this in counter to in this project that I found online. This is someone who set up a robot to do sculpting, and I just kind of abhor this idea. This is the designer has developed the robot, so it only needs to rely on people for menial tasks. So I think that we like to take the kind of opposite position, that the robot is there to augment, or to, not to supplant, but to augment the skills of the craftsperson, as opposed to just making a person come back with clay. This is a very different project. It's much more commercial. It's a condominium lobby. I worked on this with Jason Grant Henley of Charles Fort. Basically, this was the design image that they came up with. I actually did the rendering, but I had no input in the design, so I just kind of distanced myself a little bit from the design. But ultimately, it's kind of the age-old story. They come up with this interesting image, and then they sell their condos, and then it's like, okay, this thing needs to get built. They couldn't find anybody to do it. And I don't think it was necessarily for the sake of skill, but more kind of liability and anyways. So they asked me to help them. This is a scan of the space, so again, digitizing that space. This is the lobby before any of the finishes, so this is raw concrete. So we came up with a structure out of plywood, also, so for a hand-applied plaster finish, and they were very concerned with how the walls, that they wanted actually curved walls. So we did top and bottom plates out of plywood for someone to build studs over top. So again, this very kind of precise curve. And then you can test this out as a model. I actually did this after the fact, but you can do that. Instead, in reality, we went straight to the plywood. It's fire-rated plywood. This was erected. All the pieces had numbers. And because I had scanned the mechanical system, the plumbing and everything kind of fit well together and came together all at once and no problems. And so most of that stuff is actually going to be hidden, and in a way I kind of like that because the digital fabrication doesn't have to be on the forefront. It can be something that guides people in their work. It doesn't have to be the thing out there on its own. But there was one element that we used, a water jet cutter, to do a stainless steel grill. And I just bring this up because again, working with, I've never used a water jet, and if you see there's some scoring, it's not just cutouts, but there's some scoring. And at first the water jet operator said, no, we can't score, we can only cut. Then he came back and actually doing some research and said, actually I can control the acceleration and deceleration of the CNC, and we can actually do scoring. So without him, again, I think it's important to be kind of taking a collaborative position. This is the final product, the person actually kind of doing final touch-ups with the hand-applied finish. This is the last project, very different again. I had the pleasure of going to Aarhus School of Architecture in Denmark with Professor Stephen Fye and another PhD candidate, Ken Percy. And we put on a workshop there using some of the technologies that I just showed you. And the idea was that there was this alley that we became familiar with in a former chocolate factory complex. And we just asked the students, they were second-year architecture students, so they had never, some of them had done kind of 3D printing, but they'd never done any photogrammetry or laser scanning. And we asked them to do kind of a hyper-contextualized installation for some place in this alley that they wanted to, they found interesting. And we wanted to push, we didn't want just kind of 3D printing or CNC cutting or whatever. We wanted it to be part of a bigger process or a more interesting workflow. So we're using 3D printing to make casts. This is just a plaster cast. And sometimes they work, sometimes they didn't. But I'm going to show three fairly successful projects here. This one, they identified this kind of weird collection of wires. I don't have a photograph of, but a weird collection of wires in this alley and conduits. They digitized that, much like the OWL project. But again, we're encouraging them not to be afraid to kind of get down and dirty with their hands. So they're sanding. This is after the CNC cut, using sandpaper. This is the final result. The idea was they were going to cast something. Then they decided that they would rather make a latex mold, so putting latex. And then this is the final kind of weird alien project. And again, this is not per se an architectural project, but if they hadn't have done MDF, and I don't know if you can see it, but there's a lot of this kind of residual sawdust that's in that latex. It kind of added like a strange patina, and it actually looked like it should belong in this alley in a weird way. Another project was very different. There's on one side of the alley, there's a brick missing, and that's this kind of wood brick that you see. So they digitized that missing piece of wood, CNC cut that. And then on the other side of the alley, there's brick missing on one side. This side, the mortar had been worn away. So they actually digitized that area very precisely, manufactured these pieces that could fit into there. And then the point was to kind of build I guess a bridge that connected the two. And so this is the little connecting piece that they sculpted in the computer. And then they put together. And there was other kind of, we had a little kind of, I guess, vernissage in that alley, and there was lots of other projects. So in closing, some of the questions that were asked of us were, what happens when, computing bumps up against the real world? And I think that, I think it's very important, especially for students, to understand that it should happen actually quite often. That there shouldn't be any fear between going from the digital to the physical and back. And I think there's lots of opportunities that can arise from that. And lastly, there's a question about aesthetics, whether that this will lead inevitably to a new aesthetic, is that important or whatnot. But I think that ultimately my interest in digital fabrication lies in the fact that I think that architects have gotten to the point where it is so difficult to the point where there's almost a complete inability to affect architecture at a very kind of small scale. And I don't mean small scale buildings, I mean like details and textures and things like that. And so I think that it's very important, or not that it's very important, but I think that these technologies, I think, can point us in a direction that can lead architects to being able to affect architecture at a much kind of finer grain detail and bring, I think, skill back into it. Thank you.